Hello guys, welcome back to the next lecture of Python and DSA, and today we are going to learn about merge sort. In the last lecture we have seen quick sort, right? In the last lecture we saw quick sort whose worst case complexity is O n square, right? Time complexity, but average and best case is O n log n. And this we have already seen. If not, then please watch the previous lecture before watching merge sort, right? Now, before I jump to the merge sort, because merge sort is very, very important, let me tell you a few points that merge sort is also based on your divide and conquer. It is also based on divide and conquer. What I mean by that, that say suppose I have how many elements I have this in this array. I have 8 elements in this array. So will I sort all elements at once? Answer is no. Answer is no. What I will do, I will divide this array into two equal parts. That is, for first part this, second part this. So I will do the divide and conquer. That is, I will process this half 21, 20, 38, 29, 17, and then I will process for 25, 32, 9. So you see, I am dividing my work. I am dividing my work. I am not touching all the 8 elements. I am rather creating the subtask of 4 array, and then we will sort. This is how we will going to proceed with the merge sort. This is a very, very, very important point, that it is based on divide and conquer. The second point about merge sort is it is the best best sorting algorithm in terms of your time complexity. In terms of time complexity, it is the best. It's best case scenario, it's average case scenario, it's worst case scenario. Time complexity, everything is just O n log n. Now you will have a question like why it's n log n. That I will tell once we go through the merge sort. But before we go there, just know that it's the best sorting algorithm in terms of time complexity. Very, very, very important point. So these 2 points you have to keep in mind, and it requires some space. When talking about space complexity, it requires an auxiliary array to store the elements, which will be the number of elements present in this, and then we have some recursive call as well, which is log n, so it will come to on. Space complexity is order of n, but time complexity O and log n in all the 3 cases, best, average, worst. So if it is clear, now it's time to do a deep dive on our merge sort. It's time to do deep dive on our merge sort. Let me do one thing. Let me erase all of it, or let me just do one thing. Let me just take this copy of this array and paste below so that we can start our dig deep. Okay. So this is my array, guys. This is my array. What I'm saying is how merge sort works. How merge sort works. Let's start. So we will divide this array. Divide this array into 2 equal halves. Divide this array into 2 equal halves. Right. So how we will divide this array into 2 equal halves? By finding the mid. By finding the mid. First, we will find the mid, which will be nothing but here. What is the length of array? What is the length of array? 8. Floor division with 2. And why floor division? Why floor division? Because we cannot have, if I just do length of array, this we have seen in the binary search, guys, if you remember. If I just simply do length of array divide by 2, I will get in float. But can index have float value? No. It will only have integer value. So for that, I am doing floor division, so that when I do 8 floor division with 2, I will always get lower value 4. In this case, even if I just divide, I will get 4. But let's imagine I have 9 index, right? I have one more element here. I have one more element here. So suppose 65, right? So total elements will be, length of array will be 10. Oh, sorry, 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 9 divided by 2 will give me 4.5, but 9 floor division will 2 will give me 4. So we are going with floor division so that we can get the index as per the integer value, not the floating value. This is clear, I guess. Right. So we will divide this array into two equal halves, guys. So now to divide the array into two equal halves, we are considering the formula called as length of array divided by 2. Now here one thing, if you have seen my binary search video, right? To calculate mid in binary search, we have this formula lower plus upper minus lower divided by 2, right? Float division with 2. First this will be executed and then lower will be added. This is the formula, right? But in this case, in binary search, we were directly accessing the index, something like this, array of mid equal to the item which we are searching, right? So that's why this formula works for binary search. But the intention behind finding the middle in merge sort, the intention behind finding the middle in merge sort, listen to me very carefully, is just to split the array. Is just to split the array. We are not going to find any item on middle index because it is sorting. Okay. The whole intention is to split the array into two equal halves. So if I will go with the same formula which I used with binary search, lower plus upper minus lower divided float division with 2, this will not work in case of your merge sort because we will get some recursive stack trace error, recursive stack trace error. So this formula will not work because we are not leveraging or accessing the element directly on the middle index. No, we need to just split it. So that's why this will be the formula of middle. Okay. I always like to cover everything in depth. That's why I am taking so much time to cover it, right? The formula of middle. Otherwise, people will be very confused if they have watched the binary search or if they know about binary search. Okay. So now coming to this, we will find the middle. What is the length of array in this case? 8 float division with 2, it will be 4. So middle will be 4, right? So 4, that's it. So my array will be splitted into two halves. What I will have now, after this, I will have one array 21, 38, 29, 17. The array containing first 4 elements. Then I will have array containing next 4 elements. Now, what we need to do here is we need to keep repeating the same thing. Keep repeating the same thing unless I have my sorted array in both the splitted or both the halves. For example, we will again find the mid here. So what will be the mid? Like this. And then you do see a recursive call. A recursive call will happen. We will see in the code. Then after this, I will have 21, 38, these two. And then I will have 29, 17, these two. Similarly, here it will happen like this. 4, 25, 32, and 9. This will be my condition. A recursive call will happen. Now tell me, is this sorted? Is this sorted? Answer is no, they are still not sorted. So what I will do, I will further do a recursive call and will again split it, guys. This is how divide and conquer works. This is how divide and conquer works. Very, very, very important, guys. Very, very, very important. So what I will do, I will create one element 21. I will create one element 30. Not create, I am dividing, not creating anything. Okay. So 29, 17. Okay. This I have 1, 1, 1, 1. Then I will have 4. Then I will have 25. Then I will have 32. Then I will have 9. Now see, each element is now separated. Now I have each array with only single element, and array with single element is always sorted, So we don't need to further do divide and conquer. We will stop here. Now, after this, once we have done all the divide and conquer, guys, what we will do, we will now merge it. And at the time of merging, we will sort it as well. We will sort it as well. You can say what we will do. We will merge two sorted array. How? Like this. First we have this array, then we have this array, then we will take both of them and then we will sort them like this: 21, 38. Okay, then what will happen? I have this will be again be sorted, right, and merged. So this will be sorted and merged. It will like with this 17 and 29. See, earlier I was having 29 17. Now I'm having 17 29. This will be sorted first and then merged. So do you see, we need to create a function which will sort as well, and then merge as well. So it is nothing but, you can say, merge to sorted array. This program is also very important. This we will see. This is a part of merge sort. Okay. Now coming to this 4 and 25. This will be sorted and merged. 4, 25, they are already in correct order. Now 9 and 32. 9 and 32 will be sorted and merged. Right. Now this is one. These two will be joined in sorted first and then joined. So what will happen first? What is the smallest? 17, then 21, then 29, then 38. This is how it will happen, right? So earlier we were having 21, 38, 29, 17. Now we are having 17, 21, 29, 38. So we did divide first, and we reached the point where we have only single element, which is already sorted, because array having single element is already sorted, which you can see here. Now when we will merge, that so that the ascending order or lower value will come first, 21 and then 38. In this case 17 will come first and then 29. In this case 4, 25 and then 9, 32. Then similarly, when we will merge this, when we will merge this and this, which is the smallest? 17 will come first, then 21, then 29, then 38. Okay, similarly this, how it will happen? Which is the smallest? 4. Which is the next? 9. Which is the next? 25. Which is the next? 32. So you can see, this is my sorted array 1. This is my sorted array 2. Agree with me or not? Now what we will gonna do is, we will do merge to sorted array, and while merging we will make sure that we merge it in a sorted way only. For example, I have 17, 21, 29, 38, and then here I have 4, 9, 25, 32. Now these two are individually sorted. When we will merge them, which is the smallest element in this? I have 4, so 4 will come first, right? In both the array will be traversed, and we will see. Then again we have 9. Then I have 17. Then I have 21. So these two gone. Then from the remaining I have 25. From the remaining I have 29. From the remaining I have 32. Then at last I have 38. This is how I have got the sorted array. This is your merge sort, internal of merge sort, right? This is how it will work. I hope it is clear. So what we are doing first, we are finding the middle, right? And then we are creating two array, left array, which will be nothing but your array from the very beginning till your mid. And we know in slicing and all these concepts we have seen, this index is excluded. So this will be till, in this case, it will be array 0 to 3. That I will have left array as 21, 38, 29, 17, like this. Then my right array will be similarly 4, 25, 32, 9 at the very first stage, like this. Now after this, I will again call my merge sort. Because you see, we have to repeat this again and again till I have length of array. This will be my base condition for my recursive call. Length less than equal to 1, right? So I will again call with left array, and I will again call it with right array. right array. So when it will call with left array, so this will happen. It will again further create two array, and then again it will be called, and then again for right array same will be happening, and then again, then again. Like similar to this, it will happen. And finally, it will I will get some a left array, I will get another right array, and then finally we will call a function merge to sorted array, and then we will pass the final these left and right, and then it will be sorted and we'll get the result. This is how merge sort works. This is how merge sort works. Now I told you, right, time complexity is n log n. Why it is n log n? Initially I had n elements, here 8. Then I divided into n by 2, n by 2. That is 4 elements each, right? Here n by 2. Then I again divided with n by 4. N by 2 divided by 2. So it will be nothing but your n by 4. Yes, n by 4, because I again further divided. So it will be like this, n by 2 divided by 2, right? So it will be like n by 4. So I will have n by 4, n by 4, n by 4, n by 4. That is, I will have two elements here, I will have two elements here, I will have two elements here, I will have two elements here. Then I will further divide it to n by 8, n by 8, n by 8, n by 8, so on, till I get 1. So do you see? I'm dividing it. I'm dividing, right? So work done at every level is getting reduced by half, right? So total levels will be, how many levels will be there? It will be log n levels. Log n levels. This you have seen already, right? This you have seen already. The total will be log n levels, and the work done at each level will be equal to roughly, if you remove the constant, it will be number of elements, the merge which are involved. So it will be on into o number of levels, o and log n. So it will be o and log n. So this will be my time complexity. Why work done at each level will be n? Because we are only taking, or we are only considering one element at one time only. One element at one time. We are not revisiting that element. Once it is sorted, we are not revisiting. So total work done will be n. And how many levels we have? Log n. So we have n log n, right? And why space complexity as order of n? Because we need one auxiliary array to store the sorted array. Firstly, that if we even remove this, then there are log n levels, there will be some recursive call and everything. So space complexity will be order of n, right? So this is it about merge sort, right? I hope it is clear. I hope it is clear. Let me just straight away go to my PyCharm and write the code. It will be more clear. It will be more clear. Okay. Let's go to the PyCharm and write the code of it. Okay. Let me just take this array only, which I just showed you. 21, 38, 29, 17. Just taking 21. Let me just say this. 21, 38, 29, 17, 21, 38, 29, 17. I don't have two screens today, so that's why 4, 25, 32, 9. 4, 25, 32, 9. Right. Now what I will do, I will first create a function called as merge sort. Right. As we discussed, I will create one function called as merge sort because I need to sort this array. What I will do, I will create my mid as we discussed the formula, right? After this mid, I will create my left array, which will be nothing but my array colon mid starting to mid minus 1. The mid will be exclusive, and right array will be array mid to end. Till this part it is clear. It should be very straightforward. We have done till here. We have calculated left array and right array. Now we again need to do same thing. Calculate mid for this split. Calculate mid for this split. So what I will do, I will again call my merge sort. I will again call my merge sort with left array, and I will get this sorted array at the end. In recursive call, it will be happening. It will be keep on happening till I reach one element. So I will get finally this from left array, and from right array I will get this two sorted. So let me just store it in again, left array. This I will get, and then for right array, I will get for this. We will again can do debug on this. We'll see the output. This will be my left array. This will be my right array. Now, as it is recursive calls, we need to specify one base condition, guys. Otherwise, our code will fail. If length of array is less than equal to 1, this I told you at the very beginning. See, this is my recursive condition. Otherwise, it will keep on happening. We need to stop, right? When we have one elements each, we need to stop and start merging, or right? So if length of array is less than equal to 1, we need to, what we need to do, we need to just do return. We just need to do return array. Right, that's it. We just need to return array if it is length of equal to 1. This would be my base condition. And then finally, what I will do here is I will again, now, as I have left array and right array, what we are doing after getting the left array and right array, we are merging. We are merging, right? So we need to create one function called as merge. Now we will call a return merge to sorted list. Something like this I can call. Okay, it is importing now. I don't want to import from anything. Merge to sorted list, and I will pass both the array, left array, right array, so that merging happens. So for merging, I need to create another function, and merge is very simple. Sorted list, and then I will have your left array, then I will have my right array. And how do I merge it? I will create first one sorted list. This is very simple, guys. And then I will have one index, two index pointing to 0, one index I for left array. I will be for my left array, and j will be my for right array. So I will start one loop while I is less than length of left array. Clear? Till the time I is less than left array and I is less than length of, sorry, now here it will not be I, it will be j. J is less than length of right array, right? Simple. I is less than left array, right is less than right array. For example, when I got these two sorted, this 17, 21, 29, 38, right? And similarly, I got this 4, 9, 25, 32. So I will point to this and j will point to this. So how to sort? We will compare this with this, right? We will compare this with this, right? 17 with 4, which is smaller? 4. So what we will do in sorted list, which we have created, in sorted list, we will do append of array, right array. This is my right array of j. I will append this. That is, in my sorted array, I will have 4. And then I will increment my j. Increment my j. So my j will come here. Then 17 with 9, which is again smaller. 9 is smaller, then again it will be incremented and my j will be incremented to here. This is how I will compare. Then finally 17 and 25, which is the smallest? 17. So 17 will come here and now I will be incremented. Now I will come here. So we'll compare and we will keep on appending. This is how it will happen. Very straightforward, I guess. So again, in while loop, I will add one condition. If length of, length, if left array of I, right, if it is smaller than the right array of j, simple, we are starting comparing. The first element of left array is smaller than, then we need to append the left array of I. Simple. If left is smaller, append the left. This we discussed. And after appending, increment the I, because we have appended this. Else, append the right one, right array, and we will increment j with 1. Simple. Done. Dusted. But there is a flaw. there is a flaw in this code. We need to add some more condition, but that will be cleared once I tell you guys. Will tell once I run merge return sorted list. Let's first test this merge to sorted list. Okay, and let's pass this 17. Let me just take this as my left array. Just taking, it will be my 17, it will be my 21, it will be 29, it will be my 38, and then I will have my right array. This is wrong for now. We need to add for some extra condition, but why I have not done it? Because I wanted to explain you guys, right? Otherwise you will not get it. Right array. Okay. Now I'm printing it. I'm running and I'm printing it. Let's see what I'm testing. Only this. I'm not calling this abhi merge sort. Right. I'm just calling abhi merge to sorted list. Let me run this and let's see. Current file I'm running. Okay. Perfect. I gave my left array as this 17, 29, 17, 21, 29, and 38, and right array as this, and it has returned the sorted. Perfect. 4, 17, 21, 25, 29, 32, 9. I have everything. But did you notice? I don't have 38 in the output. Where did 38 go? Now say suppose let me add some more element also. Now 75, 89, 4 or 3 because 4 is already there. Let me run this. What will happen? See, all the other elements are getting ignored. Why? Why? Why it is happening, guys? Why it is happening? Why? Because we have added this end and J has reached its end. Right? Why? Because 4 first got added, then 25 got added, then 32 got added, then 9 got added. The other elements did not get added of left array. Why? Because we have added one AND condition. So this will not be true because J will exceed the value of length. So we need to add the remaining elements. And how we need to add the remaining elements? We will simply apply. While I is less than length of array, we will just simply append the remaining left of array of I, and then simply while, and we will increment the I to 1. Here the array will be sorted, obviously. It is merged to sorted array. So 3 will not never come to the end. 3 will always come into the beginning because we are merging to sorted array. Okay. We are merging to sorted array. Merge to sorted list. So it is always we have to sort it. Otherwise this program will not work. Okay. While J is less than length of right of array, we will simply append sorted list dot append right array of J, and I will do J plus equal to 1. Now let's see. Now let's run this. Let's see. Will I have 38 missing? The 38 will get added because for 38 I have added one extra condition. While I is less than array, so it will see 38 is remaining. It will just append the 38 and it will increment the I, and then it will come. This condition will be false. And similarly, if I has traversed first and J is remaining, for J also I have done. So no elements will be left. Now let me run this. See, I have my 38 as well. So it is merging to sorted array as well. Now add more elements. I will add 3. I will add 1. Because it has to be sorted, I will add 15. Okay, let's see. I have left array which is sorted. I have right array which is sorted. Right, let's run this. No, this is not sorted. Let me just sort it. This is not sorted. 35, 32. Yes, now this is sorted. Let me see the output. Yes, it is merging correct. 1, 3, 4, 9, 15, 17, 25, 29, 32, 38. It is able to merge two sorted arrays. Can you see? Can you see? So this function is working fine. Let me comment. So this will be my function for merge to sorted list. This is my merge to sorted list. I will get the list. I will create one sorted list to store the output. and then I will traverse, I will compare, and I will add the left. If it is smaller, I will increment I. I will add right. If it is smaller, I will increment j. And then finally, for the remaining elements, I will start to more loops, right? And then I will get it finally. And then in merge sort, right, I will finally call now my merge sort to test if everything is working fine, right? Now let me just call my merge sort with this array, which I have command X. I am at top. I am just calling my merge sort. I hope everything works fine. Merge sort. The array which I have is command V. That's it. Let's run this and let's see if our array is getting sorted or not. Yes. 4, 9, 17, 21, 25, 29, 32, 38. It is getting sorted. Well done. This is my merge sort. Let's see. Let's traverse it line by line. Let's traverse it line by line how it is happening. Okay, because this is my habit. I will never stop till the time you have any doubts. So let me just bring this, the epic pen here. How can I bring it? Mm-hmm. Somehow I'm not able to bring it up. Okay, anyways, let me just start how it will happen. Firstly, in the same way. In the same way, guys, this will come here. Like this will come here. I am calling this array. So if length is less than equal to 1, no, it is not. So middle will be found. Middle is 8, right? So sorry, middle is 4. Length of array is 8, so middle will be 4. Then left array will become your 21. This will be your left array initially. This will be your left array. I'm just writing, and then your right array will be this 4, 25, 32. I hope it is clear. I hope it is clear, guys. And then what I'm doing, I'm again calling merge sort with this. Then again flow will come here. Length of array is less than 1. No. Then your middle will be middle for this. Middle for this will be length of array 4. Then the flow division with 2. The middle is 2. Then for this I will have left array as 21, 38. And for this I will have right array as 29, 17. Then again for this, merge sort will be called. Then length is smaller. No, I will have this. Mid will be your 2 divided by 1, 1. Then I will have left array as 21, right array as 38. Then for this right array also I will have 29. This is how your list will be created. And then I will have 19. Then finally, length will reach 1, and all these will get returned. And where it will get returned? Here. And then we will start calling the merge to sorted list. Then it will be merged in a sorted fashion. So first, this will be merged, this will be merged, and so on. All will be merged, and then we will get something like this. So this is how it is going to happen. Okay, merge. I did the mistake. Okay, so let's run this again. I am getting the correct output. Let's test with empty array. It will, what it will simply do, it will see length is less than equal to, it will just simply return this blank array. I'm getting this as expected. Let's test it with already sorted array with 5 elements. It is giving me 5, 5, 5, 5, 5. Let's see what we have done wrong here. Merge sort. Merge sorted, merge to sorted list. J is less than right array. I less than I J if I. Oh, what has happened? 5, 5, 5, 5. Oh, wow. This. Sorry, right array equal to this. Let me run this. Yes, 1, 2, 3, 4, 5. This is also okay. I was explaining you guys and then I did this. Okay. So then finally, let me test with another scenario. Let me just do 7289. Let me just do 7289 testing with all the test cases. 7289. Okay, here I'm not storing it. Yeah, what has happened when I was explaining it, right? Something has happened. 7289, I'm calling it again. 2789. So this is my final merge sort. I hope you guys liked it. This is a very, very important program, merge sort, right? Do practice it. This is, we can further optimize it. If you don't want to store or create this sorted list extra, we can just work on the same array. We can work on this same array and we can like do something like this. We can have one array, we can accept one array, right? And we can just simply work something like this, and we will do, if I want to store left array, or I can just do array of k equal to left array of I, something like this. Instead of storing it here, I will have another array called as array, right? I will not create this to save some space. I can do like this. I can have something like this, array of k equal to right array of j ij, and I will create one another k index here. uh, just to save some space, I am working on the existing array. Okay, and then finally in both the cases I will increment my k. I will increment my k. Then finally, here also I can do some same. So I'm working on same index, guys. Same array. Same array. It's nothing fancy. I'm just trying to save the space. Okay, and I will increment my k as well in the final array. And then I am doing like this, array of k equal to right array of j, and I will do k plus equal to 1 finally, and then I will return my array, the ARR array. Okay, did you see what I have done? I have brought in the existing array, and instead of appending to the my you can say sorted list, a new list, I am just changing to the k. So k will be first 0. So first element will go to 0, and then I'm appending this k as well, incrementing this k as well. Okay, and then finally I will pass array as well here. Then let me run this 7289 2789. It is working, and we have saved the space as well by ignoring this sorted list, instead passing array as the third argument and using this. This will further reduce the space complexity. But yeah, the worst case is O n log n time complexity and O n space complexity. I hope you liked it. Do subscribe to our page. Check out our Insta. For do give it a follow on our Insta page, BigDataYatra, and we do have our website BigDataYatra.com. Try to, if you want to enroll to this full course, big data and data engineering course, use coupon BDY4000 to get flat 4000 off, and the entire course will be of 8999. See you in the next class. Bye bye.